Hi everybody, this is Miss Fred. I'm going to go over this equation that we did in class. This video is time-stamped as March 2nd. So if you're watching this later on, just do the problem like it is brand new to you. Otherwise, if you were in class on March 2nd, I'm just doing the same problem, okay? All right, here we go. We want to solve for x. So what we want to do, to remind you, is we're going to solve this equation as if there was no 3 in the front. We're going to solve it as sine x. So we're going to think this is the case, not that it is the case. And when you go to your unit circle, you know your points pretty well at this point on the unit circle. So this point on the unit circle is 1/2 comma the square root of 3 over 2. That angle happens to be pi over 3. Okay, and then we have another one on the other side here because we're dealing with sine. And so that one is going to be 2 pi over 3. Okay, why? Because sine is positive in the second quadrant. And I'll just write out that point for you. Alrighty, so getting back to the problem, I've got sine of x, so we're going to solve for x here. So x is equal to either pi over 3 or x is equal to 2 pi over 3. But that's not the problem we have. What we have is the original problem. So I'm going to convert there, go back to there. Let's go to the original. And I have sine of 3x is equal to the square root of 3 over 2. So I'm going to steal what I did in the top and just transfer it into the bottom. And so what we're going to do here is we're going to take this 3 right here and we're going to write it in front of the x's because that's really what we have. We have triple angle. Now, if we're talking about every solution, I'm going back and reminding you that this would be plus 2 pi k plus 2 pi k, and I'll write the z at the end of the problem. This is 2 pi k. It's getting a little smashed, so maybe I should go ahead and take this out. Alrighty, and this is exactly like what we did in class yesterday. And then we're going to solve it for x. So we're going to take everything and divide it by 3. So all of these terms get divided by 3. And I'm reminding you that we're doing copy, that's the pi over 3 part, switch, and then flip. And then this is 2 pi k over 3. And I'm going to do the same thing over here. Plus 2 pi k over 3. Okay, so all of that should feel pretty good to you, and I'm just going to clean it up now. Give you a good view of that. Right, you might have noticed in class that I wrote that last expression in the following way. And this is how I'm going to write it. So right here, this is your radian and this is your K. So you're going to see me write this as 2 pi over 9 plus, and then 2 pi over 3, and then times K. Because there's really an invisible 1 here. And that's how you're used to seeing it with, like, you know, 2 pi K, right? And there's a 1 underneath. So it's the same thing. So just get used to seeing that. So I won't write this line. I just wanted to make sure. That was the question I had from a student. Alrighty. Now, when I talked about, I thought I had made a mistake in class, and I didn't make a mistake. What I was thinking about before you guys took off was the fact that the solutions weren't exactly at pi over 3. That's what I was thinking about, but of course they weren't, because we are dividing everything by 3. So what do I mean by that? Well, this is what I mean. So I moved over to the graph that we saw in class, and I'm reminding you how the periods work here. So there's 1, 2, and then 3 inside the original 2 pi. 2 pi is the parent, of course. And remember, the equation that we were solving was sine of 3x is equal to the square root of 3 over 2. So that's about 0.87. So about 0.87 is going to be about right here. And that is where I'm going to put that. And then what's going on is where these two graphs intersect are the solutions. Okay, and of course they go infinite in both directions. The one I'm focusing on is the first one, because remember the answer for that one was x is equal to pi over 9, and then that's where I want to start. So that value really is right here, pi over 9. So I'm just estimating where it is. When I was doing it in class, I was concerned because I thought the answer, just to let you know what my brain was doing, is I was thinking about the original, which was x equals pi over 3, and of course that is further up on the graph, on the x's. So this is completely fine. Also, I double checked it, so we're good. So hopefully you're understanding the lesson, and I'm going to just start blazing through some of these examples. Alrighty, we're doing number 2. This is tangent x is equal to the square root of 3. Alright, so for this one, you might have recalled that I let you know that rewriting this in terms of a ratio is going to help a lot, because tangent in the definition is sine over cosine, or one way to express it. And so I'm going to rewrite this as the square root of 3 over 2 and then 1/2. So the denominators are the same. And there are two ways that you can express the positive ratios. So one is with two positive values, top and bottom, but then there's another one where you can express it where both values are negative. So you just have to make sure you do not forget the other one. So then you're going to go to your unit circle and try to check out what that angle measure is going to be. And so we are looking at, this is your sine and this is your cosine. So the value we're looking at, because it's the same for both except for the sines, of course, we've got 1/2 and we've got the square root of 3 over 2. So just to decipher what the point is, it's going to be right here at pi over 3, and then you have another one down on the opposite side here, which would be, so let's see, it is at 4 pi over 3, just to make sure you're looking at the unit circle correctly. And then just to remind you, down here we have negative 1/2 and negative square root of 3 over 2. And of course, we've got the same values, but just in the positive. Just to remind you. Okay, so now we're going to go ahead and solve this for all solutions, not just the interval. So x is equal to pi over 3. And then plus, now you got to be careful, because you have to remember that the period for the graph is pi. So for the tangent graph, just to remind you, it's starting at negative pi over 2, and the graph goes to pi over 2. So I'm letting you know that it's only half of this. Okay, which means if you look at what's happening here, here's the value that we want. We're going pi. You can see it. It's halfway around the circle. You know, I know it's not perfectly on axes, but you can see it. It's halfway around the circle. So this is pi, and then k. K is an element of z, and then finally we've got the other one, which is x equals 4 pi over 3 plus pi k, where k is an element of z. And then you are good on that one. All right, moving on to number 3. So I'm going to move into how Delta Math is going to expect you to do some of these problems, and I'll let you know which ones I want you solving for all. But in the assignment that you're doing today, it is going to be asking you to find it between, the angle that is, between 0 and 2 pi. So the way I usually write it in class is 0 to 2 pi, which is good. That means there is no like k, element of z, there's none of that. It's just straight up the radian angle measures. So now what I want to show you is this problem is written in terms of like an algebra 1 problem. If you think about it, is x plus 1 is equal to 0. So intuitively, you know you're going to subtract 1. So what are you doing? You are isolating the trig part of the equation. That's what you have to first do. So I'm going to always, beginning of the problem, tell you what you need to get by itself first. So cotangent x is what you want to get by itself. So you will just subtract 1. So it's a combination of normal equation solving with the last steps being dealing with the trigonometry. So we've got cotangent of x is equal to negative 1. Now, you can do this straight up using cotangent, but most of us are more comfortable using sine, cosine, and tangent. So here's how I would solve this, and this is how Delta Math is also going to solve this. The reciprocal of cotangent x is tangent, but you know that. So if I do this, then what I can do then is flip the fraction around. And I know this one's negative 1, so it's going to come out the same thing. I'm just making sure I color code everything for you. And you know exactly what's going on. So we're taking the reciprocal. Remember that when you're dealing with one negative in a fraction, it can be written lots of different ways. Okay, you can have it in the top, you can have it in the bottom. So these are all the same thing. It's the fact that you have 1. So this is negative 1 again. All right, now we're going to use our trigonometry. So what values on the tangent or on the unit circle will provide you with a ratio of negative 1? So when you're dealing with tangent again, you're looking for the ratio of sine over cosine. In other words, we want the values to be the same on the top and bottom. And I bet you have that memorized, or you know how to find it quickly at this point. These x and y values are the same. So this is at pi over 4. And then we want tangent to be negative. Okay, so I actually do not want the first quadrant, but you know that's the reference angle there. So I want to go the second quadrant, so this is 1 pi over 4, 2 pi over 4. This is 3 pi over 4. So that's one of my answers. Okay, and again, I'm just going to write that out for you real quick so you know why. And then tangent's positive in the third quadrant, so we know it's not there. So it has to be over here in the fourth quadrant. And looking at your unit circle, you should have positive cosine and negative sine in the fourth quadrant. Okay. All right, so what do I got? I got x is equal to 3 pi over 4, and I have 7 pi over 4. And that is what Delta Math is going to expect you to do. Okay, so hopefully that's feeling okay. All right, we're moving on to the next type of problem. We're on number 4. Yay! So those last couple ones I did for you were either ones we did in class or they were kind of review. We are now going to level up and do another type of problem. So go ahead and write that down. Now if I go back to previous mathematics and try to make a connection between the equation solving, this equation, the cosine squared x, is going to mimic 2x squared minus 1. So if I asked you to solve this, you need to think of it this way until the end of the problem. So you're just going to do your basic algebra skills that you have. And remember, you want to get rid of everything except for the trig expression. So I'm dividing both sides by 2 at this point. And then I finally have the cosine squared x isolated. But I need to get rid of the square root. So think about how you get rid of square roots. If you don't notice the square root, you can easily see how you get the answer wrong because it looks like, oh, it's cosine x equals 1/2. And that's not what this is. I'm going to write this visually in case you're only watching. So this is not cosine x is equal to 1/2. This is going to give you a totally different answer. So what is it? So I'm going to go up here. And you have to take the square root of both sides because we have that power 2 up there. So I'm going to square root both sides, and here's the thing. You have a plus or minus. Huge. You're going to lose roots if you do not put the plus or minus. So we're left with cosine x on one side. And you now have plus or minus. And what you have is, what's the square root of 1? It's 1. What's the square root of 2? It's the square root of 2. But you have to rationalize. So now you can really see why you might get the wrong answer if you're not paying attention to that square. So what you really have is plus or minus the square root of 2 over 2. And when you go to your unit circle, you're going to see that we need all 4 quadrants now. Okay, so I'm going to illustrate that for you. Okay, all students take calculus. Now, if you look at the unit circle, you know that this is pi over 4 as the reference angle. So here is pi over 4, because that's the square root of 2 over 2. Okay, remember, we have positive. So I'm going to write this out and split it up so it's super organized for you. Okay, so first I'm going to start with the cosine x is equal to positive square root of 2 over 2. So you can see exactly where the answers are coming from. So x is equal to, it's pi over 4. It's positive in the first quadrant. Okay, we're negative in the second quadrant. We're negative in the third quadrant. We are positive in the fourth quadrant for cosine. So that's 7 pi over 4. And then the next one we're doing is we're looking at cosine of x that's negative square root of 2 over 2. And so the answers for this one, because we want the negative, cosine's negative in the second and the third. So we're going 3 pi over 4 and then 5 pi over 4. And I forgot to mention at the beginning of the problem, so you need to fix it now, pretty please, is I did not put the restriction. Delta Math wants you to only put the answers in, again, between 0 and 2 pi. I'll let you know when I want the answer in infinite sets, okay? Alrighty, moving on. All right, we're in number 5 now. One thing I want to make sure you notice about every problem in Delta Math that you're working on is they're going to say find the angles. And in this particular example, they are telling you to do it in degrees. So I'm just letting you know, make sure you're reading the directions on that. If they want radians, they're going to say again that they want between 0 and 2 pi. So this is how you would know that you're dealing with the radian values and not the degree values, okay? But it's the same thing. Alrighty, here we go. Now we're back to factoring on number 5. Yeah, get excited, people. So what are you looking for? I know it looks a little bit wild. What I'm hoping you'll see is that if I change this to the equation into c squared plus 2c is equal to 0. That looks like items that you know from the past, so you would factor out the GCF. And that's exactly what we will do. So you would factor out c, and then you would get c plus 2, and then you would solve. So I want you to know, even though the expressions are getting more complex, the idea for the algebra is fine until you go to evaluate the angle. All right, so here we go. Here's the cosine squared, and here's cosine theta. So it's getting used to how these look. That's why it really helps a lot if you just start the problem by taking off all of the other letters and just strip it down. Okay, so I'm going to factor out a cosine theta. So if I take out 1 cosine theta, I'm left with 1 cosine theta. Cosine theta, and then I factor out the cosine theta here, so this is plus 2. And then it's equal to 0. So this is just like factoring, where you're going to take each part of the equation and you're going to break it up using multiplication and set each part equal to 0. So we'll start with this one on the left first. So the one on the left is like examples we've been doing in class. So we're looking for that 0. And if you know it by heart, or you just look really fast, go for it. This is cosine, and then it's 1 and 0 and negative 1. So we look at this and we know that one angle, and remember they want it in degrees in this problem. Okay, one angle here is 90 degrees. Okay, the other angle for this problem is 270 degrees. Alrighty, now we're doing the other part here, so we're going to subtract 2 from both sides. Should feel okay. And then you get cosine theta is equal to negative 2. So now you're gonna like zip over to that unit circle, but here's what I want to show you. There are two ways I can show this to you. One is just straight up on the unit circle. You'll see what's going on here. So remember the radius value is 1, and that's because we've assigned it that way. Well, we don't have a 1 on this unit circle. So it's invalid. It's not even on the circle. It's outside the circle with a radius of 2. So it isn't going to work. But because of that, same idea. If you're looking at a graph, and this is just straight up cosine, this is why it really helps if you have a good idea about how the graphs work. Here's the cosine graph. Okay, it's a little lopsided, but you got it. The maximum value here for that is 1. Okay, because remember, there's no transformation on this particular part. Okay, so I know that it says +2, but we're not doing a function moving around. We're solving an equation, but we're connecting it to the parent graph. Okay, so the minimum is -1. So like -2 is down here. There's no graph here. So this is not possible. So your solution set for this one is just going to be the 2 blue, and that's what you're going to type into delta math, are these two. Okay, so go back and double check this one and make sure you understand all the parts, because this is where we're going. We're going to start doing all of the bells and whistles. They're coming up. All right, let's do number 6. It says solve the trigonometric equation for all values between 0 and 2 pi. So pay attention to the fact that they're asking you in delta math to give the answer between that, just 0 and 2 pi, and not the infinite answers. Okay, here we go. Right, so just to liken it to previous kinds of things that you have solved in the past, you're going to divide both sides by the square root of 3, okay, in order to solve this. So we are going to do that. So we want to get cosecant x by itself isolated, and we're going to square root both sides. Not square root, we're going to divide both sides by the square root. That's what I should have said. So I got cosecant of x is now equal to 2 over the square root of 3. So what is the reciprocal of cosecant? So we're going to flip everything upside down using this identity. We know that this is going to be sine of x is the reciprocal. So now we can just flip the fraction over, and we now have the square root of 3 over 2. And that's cool. Why? Because that's easily found on the unit circle. So you don't have to worry about the cosecant, which is nice. So going over to your unit circle, that value here is 1/2 comma square root of 3 over 2. And that is at pi over 3. And remember, all students, so we're in the second quadrant now also. And that one is at 2 pi over 3. And so the rest of the values are going to be negative, and so that's all we need. That's it. Hope they're getting easier for you. So x is equal to pi over 3 and 2 pi over 3. And that is it. Okay, let me know in class if you're having any issues with these, and I hope the delta math goes well. You got to write them all out. And I will see you later.